So a couple more interesting things can happen with circles. So this next theorem says that the perpendicular tangent theorem. It says a line is tangent to a circle if and only if it is perpendicular to the radius at the point of tangency. So some new vocab words. So tangent means it touches in one spot. It's just going to come up and share a point on the circle. It doesn't intersect the circle, it just touches the circle. So this right here is a tangent line. Now, it's tangent circle if and only if. So this means this works both ways. If I know it's tangent, I know it's perpendicular. If I know it's perpendicular, I can say it's a tangent. What we really care about is the fact that a radius that touches that tangent point is always going to be perpendicular. And the reason we care so much about that is because it makes that beautiful right triangle, which means the Pythagorean theorem is in play to help us find things about that triangle. Another theorem with tangents is the congruent tangent theorem. And this says if two segments are drawn from the same exterior point tangent to the same circle, they become congruent. So if I take this point C clear out here and I draw a tangent line back to circle O, and I draw a different tangent line back to circle O, those pieces are automatically congruent. If you look at quadrilateral OACB, you can see that it is a kite. And so that should feel pretty comfortable. If we drew the perpendicular bisector, which is also the diagonal, every property we know from our kite unit in Unit 4 is true. So we see those overlapping theorems and that reinforcement of what is going on. So how would we use this? So the first problem here is a tangent problem. So if I see this radius, AB, and it's touching in one spot with my tangent line, CB, I know this is a right angle. And as soon as I know it's a right angle, then this length, AC, I can call it D, I can call it R, I can call it whatever I want, becomes my hypotenuse. And so I know that D squared is equal to 5 squared plus 8 squared. And so I know that D squared is equal to 89. And so D is the square root of 89, which is approximately 9.4. This next problem is a perimeter problem. And I highly recommend that you get some colored pencils because that always makes these go a little bit cleaner. We're using that congruent tangents theorem that we just talked about. So I have this point A, and if I go back here and A to B is 4, then A to H is 4. Careful and don't overgeneralize. From C back to D is 8, so from C to B is 8. If E to D is 3, then E to F is also 3. By parts to whole, if this entire thing was 6, E to F was 3, then G to F is also 3, which means that G to H is 3. So it always has to do with those vertex points going back, not these 2 points on the same segments on the same side. So that's the first problem and the first thing to be careful of. It's asking for perimeter, so be careful to not add numbers twice. So the length of A to C is 12. The length of C to E is 11. G to E is 6, and A to G is 7. So if I add up 12 plus 11 plus 6 plus 7, I find my perimeter is 36 units. Just be careful to not add a piece and the whole and end up with a little bit extra in your perimeter. Now this problem is a tangent problem, but you have to be pretty careful and observant about what you need. Again, I like to use color so I can see exactly what I'm doing. And if I highlight the triangle that is my right triangle, and I want to come over here and use C, my hypotenuse, I realize I don't know it. I know this exterior piece is 8, but it appears that I don't know this interior piece, except that interior piece is a radius. So is this radius. So that means this interior piece is 12. So it means my entire hypotenuse is 20 by parts to whole. So be sure you're always aware of missing pieces and that you're using the right pieces in your formula. So when I go to set up my Pythagorean theorem, 20 is my hypotenuse, so 20 squared is equal to x squared plus 12 squared. So 400 is equal to x squared plus 144. If I subtract 144 from both sides, I get 256 is equal to x squared. The square root of both sides, x is 16. Remember, hypotenuse is always your longest side, so it would not make sense to use 8 in your formula. So just be aware of your lengths and the relationships of your sides in these problems. Good luck on your homework.